Good morning everyone. Now I would like to explain about basics of radar system. First, radar system full form is RA stands for radio, D for detection, A for and R for ranging. Radio, detection and ranging. So clearly name tells that we are using radio waves for the detection of objects and also used to find the distance between object and the radar system. So we know that the radar system works with the principle of bat. Bat moves in the night times by emitting ultrasound waves, and immediately if any object is there, it gets some reflections and takes turn immediately. So similarly radar system is also operating with the same principle, and it emits the electromagnetic signals. If any object is there in front of the radar system, then some reflections will be there, and based on the reflections some processing will be done, and we are calculating the distance and several parameters also. The basic radar system consists of a transmitting section, transmitter, and a receiver and antenna. Transmitter is used to generate one RF signal. That RF signal will pass through antenna and radiate into the free space. Antenna here acting as a transducer which converts RF signal into electromagnetic signal. Now, so the output of antenna is an electromagnetic signal. It will emit EM waves. So as it emits the EM waves, radar system is also known as electromagnetic system. Suppose if any object is there, some reflections will be there in several directions. Some part of the signal is again re-radiated back towards the radar system. It will be collected by the antenna and the signal will be sending to the receiver for further process. Here the receiver is going to determine the signal and find the range, nothing but distance between the object and the radar system. So what are the internal blocks of the transmitter and what are the internal blocks of the receiver? They are depending upon the type of the radar system and type of the parameter evaluated respectively. Suppose we are going for transmitting section. Say there are several radars we have. Suppose we have pulse radar, CW radar, FMCW radar and so on. Several radar systems we have. Suppose if you are taking pulse radar into consideration, we are emitting pulse modulated signal. In the case of CW radar, a continuous wave is going to be emitted from the radar system. In the case of FMCW radar, we are emitting frequency modulated continuous wave. The same continuous wave will be undergoing for a frequency modulation and it will sending into the free space. Now, in that transmitting section depends upon the type of the radar system. Suppose if we are using a pulse modulated radar system, then we need a pulse generator, we need a carrier, then these two will undergo a modulator and then amplified and released into the free space. So here in the case of pulse modulator, we need a pulse generator and we need an RF signal generator and modulator and then amplifier. So these are the transmitting section blocks in the case of pulse radar. Suppose in the case of CW radar, if you are taking, we need an RF oscillating signal generator and amplifier. These two are sufficient in the case of CW radar. Suppose in the case of FMCW radar, along with these two, we need to go for frequency modulation technique. So depends upon the type of the radar system, we are using what type of blocks in the transmitter section. And next, coming to the receiver, in the receiving section, we are going to determine whether the range or velocity or direction of the target. We can determine the range between the object and the radar system, and at the same time, if the object is in motion, if it is not a stationary object, if it is in motion, then we can calculate the velocity of the object also. And if the object is moving, then we can determine the direction of motion also. Direction of movements, that depends upon the Doppler. Velocity and direction we can determine by using the Doppler frequency FD, Doppler phenomenon FD. Now, Doppler, what do you mean by Doppler phenomenon? How it helps in the determination of velocity and direction? Doppler is an Austrian physicist. He observed this type of Doppler effect. Doppler effect is nothing but when either source or observer is in motion, the change in the light or sound wave is nothing but the Doppler effect. So depends upon the Doppler effect. If the object is in motion, suppose this is our radar system with an antenna, and here it is the object. Suppose this object is moving towards the radar system or it is moving away from the radar system, can be determined by the Doppler frequency. Suppose if I am going to emit the waveform from the radar system with a frequency ft. Now the transmitted signal is having a frequency ft. When this wave touches this object, if this object is a stationary object, the reflecting signal is also having the same frequency ft. If this object is not a stationary object and if it is in motion, then if the object is moving towards the radar system, the resultant frequency will be ft plus fd. Here this fd is due to the movement of object and plus fd is due to the movement of object towards the radar system. If it is moving away from the radar system, then the resultant frequency is ft minus fd. It is moving towards and it is moving away from the radar system. So in general, when we are taking the Doppler effect into consideration, we are taking fd plus or minus ft plus or minus fd. So plus is for towards direction and minus is for away from the radar system direction. So in this way, that depends upon the Doppler frequency plus or minus, that means the original frequency, whether it is decreased or increased, that determines the direction of movement of the object. And in the similar way, velocity can be calculated using the same Doppler frequency fd, because these two are in proportional to each other. So this is the basic radar system concept, how the transmitter sections will be there and what are the receiver sections and what are the various parameters we can evaluate and how the basic principle is going on. And the next one is range to the target. So in the case of radar system, we are seeing there are three main important blocks. They are transmitter, receiver, antenna, along with one object that is optional. Let us consider the distance between the object and your radar system is r. We know the basic formula, that is distance is equal to speed into time. Distance is equal to speed into time. Here we are going to write the parameters of this radar system like distance, speed and time. All these are belonging to the electromagnetic signal that is emitting from your radar system. So distance traveled by the electromagnetic system, speed of the electromagnetic system and time taken by the electromagnetic system to start its journey until the object and again reaches the radar system. That is, these are the three parameters comes for the electromagnetic signal itself. Now distance, the total distance traveled by the electromagnetic system, electromagnetic wave is, that is starting at this location and goes until this object and again coming back towards the radar system. We need to consider the total round trip, then only we can determine the distance and time of the EM wave. So distance traveled by the EM wave, one is in the forward direction, total distance is r, again in the reverse direction the total distance is r. So total distance traveled by the EM wave is 2r, forward direction and backward direction. Next, speed of electromagnetic wave. Speed of electromagnetic wave is nothing but speed of the light, c into time. Let us take the time taken by the electromagnetic signal to start its journey from the antenna until it touches the object and again coming back towards the antenna. So the total time taken by the radar system signal, that is t. So the range to the target r is equal to ct by 2. It is in a simple way we can determine the range to the target in terms of velocity of the EM wave and time taken by the EM wave for the round trip. This is range to the target. This is not the actual range equation because the range equation involves all the parameters of transmitter, receiver, antenna and object. We need to consider, if you are going to consider all the parameters of the existing complete radar system, then that will be a range equation. It is just a simple formula, r is equal to ct by 2 based upon the basic equation distance equal to speed into time. Okay, thank you.